So now we're going to take a look at gases. Gas particles are spread very far apart, especially compared to liquids and solids. They move very, very quickly, so they have long whooshes in the particle diagrams. Gases have no definite shape or volume. This means, unlike liquids and solids, they can expand and they can contract. Like liquids, they take the shape of the container that they are in. We assume that gas particles have no intermolecular forces or no attractions between the particles. And as we said before, they move very, very quickly. So now we're going to look at our different measurements that we use for our states of matter. And we have four main measurements that we use. We use mass, volume, temperature, and pressure to measure our solids, liquids, and gases. So mass we can use for all three states. And mass is defined as the amount of matter in an object. We can measure mass using a balance when we are in lab. Now, our units for mass are based on grams. Using our metric prefixes, we can also have milligrams, which is 1,000th of a gram, or we can have kilograms, which are 1,000 grams. Next, we have volume. We can use volume for solids, liquids, and gases. It's defined as the amount of space an object takes up or occupies. We can use different tools to measure volume in lab. We can use graduated cylinders, we can use beakers, we can use pipettes. It all depends on how precise of a measurement we want. We measure volume primarily in liters. Just like with mass, we can have milliliters, which is 1,000th of a liter, and we can have kiloliters, which is 1,000 liters. Next, we have temperature. Again, we can use temperature for all three of our states of matter, and temperature is the degree or intensity of heat present in an object. So temperature or substance. So temperature is related to the kinetic energy or the motion of the particles, and we use a thermometer to measure temperature. We use two units in this class. So we use Celsius, which is degrees Celsius, or degrees C. Celsius is based on water. 0 degrees Celsius is the freezing point of water, and 100 degrees Celsius is the boiling point of water, and then it's just divided into increments from there. Kelvin is considered an absolute temperature scale, where 0 Kelvin means absolutely no motion, no particle movement at all. To get to Kelvin, we do degrees Celsius plus 273. Pressure is our last measurement, and it is specifically for gases with our states of matter. So you can measure pressure with solids and liquids, but it's not typical, and we're not going to in this class. So we're going to use pressure for gases, which is the continuous force exerted on or against an object by something in contact with it. So we're looking at the contact between gas particles and the wall of a container. We can use multiple things to measure pressure. We can use things called manometers or barometers. In this class, we're just going to use digital sensors. There are lots of units for pressure. The first is atmospheres, or ATM. The next one is millimeters of mercury, or mmHg. And then the last common one is called torr. So those are the different types of units that we're going to use for our different measurements. We're going to explore each of them a little bit further as we get more in depth and as we start using and applying these measurements in different situations.